Hi everybody, the purpose of this video is to go over section 3.3 where we'll be talking about the future value of an annuity, and in this particular video we are going to focus on what an annuity is and the problems associated with homework 3.3a. Okay, well, annuity is a financial instrument. It could be a loan, it could be an investment, where it involves a sequence of equal and periodic payments. And this is the major contrast between an annuity and a compound interest loan or an investment. In a compound interest loan, you are given a sum of money at one particular time, you wait a period of time, and then you repay the money with the interest. In an annuity type of loan, you are given a period of money and then you pay it off on a periodic basis. Like in a mortgage or a car payment, it would be a month-by-month payment until the balance is zero. If it was an investment, you would deposit the money, you would wait a certain period of time, and then after that period of time, you would withdraw the money. That's the way a compound interest investment works. Deposit it once, you wait, you withdraw the money, and the interest you've earned. In an annuity investment, you deposit the same amount of money at periodic intervals over a period of time, and then once you're done, you withdraw that money. Now, there are two ways to make those split payments. They can be done at the end of a time interval. We would call that an ordinary annuity, or it could be done at the beginning of the time interval, and we call that an annuity due. We will be looking at ordinary annuities. We will not be looking at annuity dues. And of course, the amount or the future value of that annuity is going to be equal to the sum of all the payments made and the interest earned. So what does the formula look like? Well, it looks like this. This right here is FE is the future value. If it's annuity in terms of an investment, it will be the amount that you get back. Kind of like the A in compound interest. PMT is your periodic payment. In other words, the amount of money that you are going to pay every time period, whether it be monthly, semi-annually, quarterly, annually, weekly, whatever. I is the interest rate per payment period, and N is the total number of payments. Now, we've seen those values before. Specifically, I is equal to the annual interest rate as a decimal divided by M, which is the number of payment periods per year. And then N, the total number of payments, is going to be equal to M, the number of payment periods per year, times the number of years of the loan. So that makes that makes pretty decent sense there. Okay, now, what is this thing called a sinking fund? A sinking fund is an account that is established for accumulating funds or accumulating wealth to meet future obligations. Basically, it is an investment. And of course, we can also use our annuity formula for financial planning. For example, suppose you have a certain financial goal in mind, whether it be the down payment on a really hot sports car, or if you're saving to send your kid in limestone, hoping that there's no inflation. Then this formula, which is really nothing more than our original compound interest formula solved for PMT, will give you an idea of what kind of monthly periodic payment you would need to actually achieve that financial goal. And with that in mind, let's head on over and work on some problems that you will find in your homework. Okay, so here is our homework setup screen. Notice that this right here is the first problem for homework 3.3a. Over here I have a calculator, and of course this is OneNote where I'm going to be doing most of my work. And here is my first problem. Here I want to find I, the rate per payment period, and N, the number of payment periods for the following annuity. I am making quarterly deposits. In other words, one deposit every 3 months, or 4 deposits per year, are going to be made for 3 years into an annuity that pays 6.5% compounded quarterly. Okay, so the equations that we're going to be looking at are the following. The first one is our interest per payment period. That is I. and that is going to be equal to the annual interest rate as a decimal divided by the number of payments per year, which is M. Okay, the total number of payments, which of course is going to be N, is going to be equal to the number of payments per year, which is M, times the length of the loan in years, which we will call T. Now, in this particular case, we are making quarterly deposits. That tells me that M is equal to 4. Whenever you see the word quarterly, you think 4. We are making deposits of $800, so our payment is $800. You probably don't need that information, but we're going to write it down anyways. And the loan is going to last for 3 years. So T is 3 years. And our interest rate is going to be 6.5%. And of course it is compounded quarterly. The compounding frequency and the number of payments per year will always be the same. And as a decimal, we will write that, we will divide that by 100, and that will give us 0.065. Okay, with that in mind, we can figure out what I is. I is R over M. Well, R is 0.065. M is equal to 4. And what is that? Well, let's figure that out in our calculator. That is going to be 0.065 divided by 4. And that is our value for M. And we want this down to 4 decimal places. So that would be 1, 2, 3, 4. Well, let's just go ahead and write this down. This is going to be 0.0162. That's my 4th decimal place. This is my 5th decimal place. Since this is 5 or higher, I need to round up, and I will round to 0.0163. And that's what goes in here. 0.0163. Okay. Now the next one is N, and remember N is equal to M times T. Well, M is going to be equal to 4, and then T is equal to 3. And we can do that. 4 times 3 is 12. So we'll have a total of 12 payments for this particular financial instrument. And there you go. That is how you do the first problem. The second problem is just like the first problem. It's the exact same problem, just with different numbers. Now, once again, we're making annual deposits of $3,200, but we probably don't need that information because if we're looking for I and N, the payment doesn't particularly matter. But let's go ahead and write that down anyways. So let me just choose a different color. And here we will have for 2. So this is 1, this is 2. We will have, well, first we have annual deposits. That implies that M is equal to 1. The payment is equal to $3,200. We are doing this for 5 years. T is equal to 5. And then the account pays an interest rate of 0.755%. So R is equal to 7.55%, and as a decimal, that's going to be 0.0755. Once again, we are interested in figuring out what I is. I is going to be R over M. R is 0.0755. 0.0755. M is equal to 1. So this is just 0.0755. Now, in our box here, that doesn't tell us how many decimal places we should put in. But notice that since our decimal terminates, we should probably put in all the points. So let's go ahead and do that. 0.0755. There you go. Now for N, well, once again, N is going to be equal to our number, the number of payments per year, which is 1, times the total number of years, which is 5. So this is just 1 times 5, or 5 total payments. So we have a 5 here. For our next problem, we basically have a direct application of our future value formula. Here we want to find the future value, FV, if n is equal to 48, if I is equal to 0.03, and if our payment is equal to 78. So this is really nothing more than putting in the numbers and seeing what we get. But let's go ahead and categorize what our numbers is. First we have that n is equal to 48. I is equal to 0.03. I is equal to 0.03. Payments equal to 78. And now we know everything to figure out what the future value is. So making our substitutions, we are going into this particular formula. See, we have PMT, I, and N. We can go ahead and do this. We are going to have that our future value is equal to 78 times 1 plus 0.3, or 1.03 raised to the 48th power minus 1 over 0.03. Okay. So to compute this in on my calculator, the first thing I'm going to do is I'm going to compute this right here, and then I'm going to multiply it by 78. So this is how this is going to go. To compute this, since I have these two terms in the numerator, I'm going to use my parentheses. So I'm going to start with parenthesis 1.03 hat exponent 48. I'm going to use my cursor to come out of the exponent. Wait, that's a 45, not an 8. Let me change that back to an 8. And let me make this a little bit bigger. Okay. Cursor to come out of that, minus 1, close the parenthesis, divided by 0.03. I'm going to hit enter. And that number right there, the 104.408396, is this value right here. Then I'm going to multiply that by 78 times 78. And there is my answer. I have that for my future value. Is going to be equal to 8143.854. And this will round to $8,143.85. Putting this into MML, we have 8143.85, and there you are. Okay, we are halfway through the first homework problem set. Here's the next one. Now here we want to figure out what payment is. Okay, now we can use this, or come up here, we can use this formula right here, which is basically nothing more than the rearranged version. So let's go ahead and put this down here. And notice that we have a future value of $5,208. N is equal to 22 total payments. The interest rate over the payment period is 0.04. And now we can just go ahead and substitute. We are going to have that our payment is going to be equal to 5,208 times 0.04 divided by 1 plus 0.04, or 1.04 raised to the 22nd power minus 1. So that's what we need to compute in our calculator. And how in the world can we do that? Well, we can do it like this. First, we can multiply the two values in the numerator together. So that would be the 5,208 with the 0.04 times 0.04. Then we can divide it. And now to do this part, we're actually going to need to use parentheses. So parenthesis 1.04 raised to the 22nd power minus 1 Oh, hang on a second. Let's back up. Delete. We had to come out of the exponent first. Now, minus 1, close the parenthesis, and now hit enter. That right there is our present value. And what do we have? We have that payment is equal to 152.067. And notice here we have a 7, so this is going to round to $152.07. That's supposed to be a dot. There we go. Let's see if I actually got that right. 152.07. Okay. And this brings us to problem 5, and it's pretty much more the same. However, now we want to use our future value formula, but we are looking for n. So that's going to be a little bit more challenging, but nonetheless, we are going to be using this formula here. Okay, so we have that the future value is going to be $4,000. The interest rate over the payment period is going to be 0.05. We know that the payment is going to be equal to $800. And we need to figure out what n is. Okay, so let's just basically start filling out a formula here. We are going to have 4,000 is equal to 800 times 1.005, or 1.05 raised to the nth power minus 1 divided by 1.0. No, correction, that's not right. We're going to divide it by 0.05. 0.05. Okay, now the first thing that we can do is we can multiply both sides of the equation by 0.05. And then we can divide both sides of the equation by 800. If I do, this cancels with that 800, cancels with that 800, and then this 0.5 cancels with this 0.5, and we have on the right hand side 1.05 raised to the nth power minus 1. Now over here we have 0.05 times 4,000 divided by 800. Let's see what that is. 0.05 times 4,000, 4, 1, 2, 3, divided by 800. That happens to be equal to 0.25. 0.25. Now I can add 1 to both sides of the equation, so plus 1 here, plus 1 here. And then when I add vertically, these cancel. I have 1.25, and that is going to be equal to 1.05 raised to the nth power. And now I can take the common log of both sides. If I do, I will have that the common log of 1.25 is going to be equal to the common log of 1.05 raised to the nth power. Okay, now using the power property of common logs, we can rewrite this as n times the log of 1.05. That's going to be equal to the log of 1.25. And now we can solve for n by dividing both sides by the common log of 1.05. These will cancel. and we will be left with that n is equal to the common log of 1.25 divided by the common log of 1.05. And that will be equal to, well, let's find out over here. Now for the common log, we're going to use the log button, which is right here. Log 1.25, close the parentheses, divided by log 1.05, and then hit enter, and we get 4.573. 4.573. Now here we want to round up to the nearest integer as desired. So since we have 4.5, no matter what, since we have something over here, we want to round up to 5. So this will round up to 5, and that is what I should be putting into here. And it is correct. Okay, and this brings us to our last problem in this particular assignment. And here it is. And here we have, recently, More Money for You offers an annuity that pays 5.4% compounded monthly. And the question is, if $1,051 is deposited into this annuity every single month, how much will we have in this account after 6 years, and what is the interest? Well, once again, we will be using this formula. And now all we need to do is dissect the question. So let's take a look at that question. Okay, the first thing is, we are offering an annuity that pays 5.4% compounded monthly. So right there in that particular phrase, we know that our interest rate is 5.4%. Dividing that by 100, we find that our interest rate as a decimal will be 0.054. And we're also compounding monthly, and since there are 12 months in the year, we have that M is equal to 12. We also have that our payment is going to be $1,051 every single month. So PMT is equal to $1,051. And we want to know how much is in this account after 6 years. Well, that implies that T is equal to 6. Okay, well, notice that our formula uses the parameters I, which is the interest rate over the payment period, and N, which is the total number of payments. As before, I is equal to R, the annual interest rate, divided by the number of payments per year, which would be M. That is going to be equal to 0.054 for R. And then that will be divided by 12. And that will give us 0.054 divided by 12. That gives us 0.0045. So I is equal to 0.0045. Now what about N? Well, once again, N is going to be equal to our compounding frequency, or our payment frequency, which is going to be 12, which is M times T, which is the duration in years. Now we have that M is 12, and the duration is 6, and 12 times 6 is equal to 72. Okay, so now we know our I, we know our N, and we have our payment. So now we know everything that we need to figure out what the future value is going to be. So our future value is going to be equal to our payment, which is $1,051, times 1 plus I, that is going to be 1 plus 0.054, no, actually, this is I. 0.0045, so it's going to be 1.0045 raised to the nth power, which is 72, minus 1 divided by, well, I again, which is going to be 0.0045. Okay. Once again, we can do this in our calculator. First, I am going to compute this, and then I'm going to multiply this by the 1050. So to do that, I'm going to start off with parenthesis 1.0045. I'm going to raise that to the 72nd power. I'm going to get out the exponent, minus 1, close the parenthesis. And then I'm going to divide that by 0.0045. And that's what I get. I got that this part right here is equal to 84.80950. Because I'm not going to really so that's what this is. Of course, I'm not really going to use that. What I'm going to do is I'm going to take my 1051, 1051, and I'm going to multiply it by that number. So times, I'm going to go up, highlight that number, hit enter again. And I get a future value of 89,134.78. And since the third digit's a 1, I know that I'm going to have $89,134.78. Oh, and we were asked to round to the nearest dollar. I did not see that. So if we're going to round to the nearest dollar, we want to look at the decimal place right here. That is a 7, so we are going to round up, and this will round to 1,135. And there you go. Now, the question here is, what is the interest? Well, remember, the interest is going to be equal to the amount that you received minus the amount that you deposited. So basically, the amount you get minus the amount you pay. Okay, so what was the amount you got? Well, the amount you got was the future value, whatever that was. The amount you paid, well, you paid the amount, we're going to call it payment, and you made that payment n times, which is 72, or just n times, so payment times n. Now in our particular case, the future value is 89,135, 89,135. The total number of payments is equal to our monthly payment, which is 1,051, times the number of payments, which is 72. And now we can compute that on our calculator. That's going to be 89,135 minus 1,0,051 times 72. And that is our interest. The interest that we earned is going to be $13,463. And that's what we want to put in here. 13463. And there you go. And that is how you do the first homework problem. So if you have any questions, please feel free to contact me. Otherwise, stay tuned while I take on homework 3.3b. And until then, this is Bob Boyle, signing off.